Our next speaker is Ian Ross from the CHTC, who is one of our GPU and AI experts. And as a condition of speaking, I told him he could have no cats and dogs examples in his slide. But the sort of person he is, I realized I framed the question wrong. I should have said no cats or dogs. Thank you, Ian, and see if you can find my problem here.
All right, we will see. And I'll also point out that Marone gave me a new identifier on Monday that I'd like you to use next time. That is Dr. Ian Ross, AI coordinator. Oh, looks like we're sharing. Okay. Yeah, so I'm here to talk a little bit about the Path ML supplement, and I will describe some of the work we've been doing, some of the experiments we've been running, some of the lessons we've learned, and some of the potential things that we think that we can do a little bit better to support ML and AI workflows using Path tools. Okay, so what is the supplement? So this is something that not quite a year ago, we added a supplement to Path to profile the effects of training and inference using distributed heterogeneous capacity, right? So the idea is we use HTCondor annexes to run training jobs into National AI Research Resource sites, NAIRR sites. And then we kind of do some exercises. We figure out, okay, what happens if we start training over here and then move over here and then move over here? And if we do these permutations dozens of times, do the models at the end come out the same? Are tools able to easily use these resources from a single access point? How does Pelican work? How does Condor work? Are we doing the right things to support ML and AI workflows? So for those of you who aren't familiar with NAIRR, so it's a big NSF initiative that is designed to lower the barrier of entry to get resources, computing resources to researchers in the US to do AI and ML work. And so we applied and received allocations at 6 different sites. So we got some at Expanse, Bridges, Anvil, Delta, Jetstream, and AWS. So what are we actually doing here? So we teamed up with Tony Gitter, who's right in the middle there. So if you have science questions, I will redirect directly to him. But the idea is, his team put together a protein language model that basically, it's a multi-stage training process. We start with simulations, we train a model, and then we fine-tune that model based on experimental observations. At the end, we have this model that takes in kind of protein sequence mutations and makes some kind of prediction of the physical implications of those mutations. And so again, the idea here is we do this training process. We start training it at Expanse. We move it to Delta after a few epochs of training. Then we move it to Bridges. And we just kind of go through these permutations a bunch of different times and make sure that we are able to move these model weights, able to move our data, able to move our container images into these different NAIRR resources and create a scientific workflow that we don't accidentally break while we're moving things across these different ecosystems. So we don't have a lot to show just yet, but things are progressing pretty well. We have the training process working in Delta, Expanse, and Bridges at the moment, in addition to the OS pool in CHTC. I'm going to talk about some of the kind of wrinkles that we tripped across on the way and kind of what it took to iron some of those out. And at the same time, I'm going to talk a lot more about sort of our workflow generation and our workflow kind of concept further on. And things, like I said, are working fairly well. I think documentation, out of the 791 pages, the ones that I read were pretty good in terms of setting up annexes and getting these jobs going into these different sites. I had good experience with the HTCondor command line tools, the noun verb tools. There are a few odds and errors here and there that I'll talk about on the next slide. And I'm also using the OSDF. So my apptainer image and the data sets have been stored in OSDF since the start, and I have had 0 issues with it. So great success on OSDF. Thank you, Brian and his team. I will say that organization is a bit of a pain point. As Doug said in his talk yesterday, every facility is a snowflake. Everything has a little bit subtly different interfaces, kind of different modalities that it just takes time to figure out how best to operate within each of these different resources. Some of the pain points, our training process takes, depending on the hardware, somewhere 12 to 24 hours. And these long training epochs make for very painful mistakes, and it takes a lot of time to kind of iteratively figure out exactly what's going on. So we tried scaling things back to do smaller data sets, but some of the issues that we were seeing only happened at kind of the full scale. So it's really expensive and difficult to troubleshoot these jobs because when you're running in the Annex, you can't, one of my favorite go-to tools is Condor SSH to job, but you can't do that within the Annex. So it's a bit of a tricky iterative development process to figure out exactly what's going on with the sites inside. Very minor interface thing that has embarrassingly tripped me up for a little while. In our job submit language, you can just say request memory 128 gigabytes. But when you're specifying the memory of the Annex that you want to spin up, you have to specify the number of bytes and megabytes. And I very stupidly just added 3 zeros to 128 and then was like, oh, why isn't stuff working? Oh, that's not how gigabytes work. And then the big thing, which is a configuration issue that I stumbled on, is that I was running these experiments on our OS pool AP, and all jobs have a job duration category assigned to them, which creates a maximum runtime of 24 hours for those jobs. When epochs take, 12, 18, 25 hours, it's very frustrating to have these jobs cut off because of AP policy when I'm kind of paying out of my own pocket to run them at the Annex.
So why is this surprising? Why do you think that it's not your responsibility when submitting a job to think about how long will it run and to tell the AP that rather than just placing it and assuming I can run forever?
I think it's more that it was hidden until,
But why didn't you assume that it's your responsibility to tell the AP how that what bothers me about it is it's a pain, but I think it's irresponsible to come to an AP and drop a job and assume it will run for 500 years.
Well, I was setting lifetime on the Annex because I knew the job would be 24 hours. What I didn't realize was the job itself.
Yeah, but the Annex is not the AP.
Yeah.
And these are two. I'm even struggling with understanding why the runtime of the epoch makes the debugging difficult. Is it the debugging after the epoch finishes, or is it the debugging? And can you debug with a smaller model or with something that takes less time? I mean, are the bugs model specific, or are the bugs tied to the model? These are the kind of questions that I am pondering when I see it's painful.
Yep. So I mean, in that case, it was kind of handling the checkpoints at the end of a job.
But is it a function?
Smaller data set.
Yeah, but is it a function of the size of the model?
Yeah.
If the checkpoint bugs or difficult that you run into depend on the size of the model.
So the checkpoint case, I should have been testing on a smaller data.
That's my point.
Yeah.
So some of these things would have expedited it.
Yeah.
Okay.
Yeah, and then as I mentioned, organization and job management is absolutely critical. And so another effort that I undertook was taking one of our fellow from last summer's, Tin. He created a DAG generator that basically creates shish kebabs of training jobs, which is exactly what we want. So, I'll show on the next slide what they actually look like. But he created kind of the scaffolding of this thing, and then when I wanted to build on top of that, and I didn't want to necessarily create a production level tool that everyone can use and everyone's AI workflows should use this thing forever. It was more about kind of looking at what we don't really support well using kind of native DAGman. What are the pain points and what are people kind of doing over and over and over on their own that we can potentially smooth out and ameliorate in the future. So the kind of mental model here for these kinds of ML workflows is that you have some kind of experiment. And each experiment has some number of training runs, and those training runs have certain qualities. So maybe you're splitting every epoch, maybe you're splitting every 5 epochs, maybe you're changing parameters across these different training runs. The job submit descriptions within each individual training job is pretty similar, but you might have minor differences. For example, what hyperparameters or what site are you targeting in my case? And then you can also kind of build out a little bit more complicated logic. So after you train for a little bit, you can add little side evaluation nodes. So this is kind of the process for creating an experiment that then has a number of different training runs. And so I thought, okay, well, I've been doing Kubernetes stuff, and Kubernetes stuff is often expressed in YAML. So I will just create a YAML kind of little mini file that explains what the experiment actually is. What's the name of the experiment? What are the variables involved? And what are the templates for the individual training jobs? I wrote a very simple DAG generation script that reads that in and kind of creates the DAG workflow from there. And then I added some special sauce just to make my life a little bit easier in terms of slotting in these subtle differences between resource sites, and then handling nodes for service and pre and post script nodes as well. And so this is kind of the example of one of these experiment YAMLs. Up top there is the submit description template, and this is where I can define places for slotting in different resources for different sites. And here we just kind of have I'm showing the way that the variables propagate from sort of the configuration into the jobs through the arguments in this case. And again, the script kind of reads these variables and just kind of fans these out automatically and will create a DAG that creates, in this case, my example parameter here is an alpha, and I want it to start at 0 and run to 10 in steps of 1. And so it will kind of create 10 different training runs with that alpha variable plugged in for each of those training runs. And then the other thing that this kind of workflow requires is the actual creation of the annex as we go. And so you can't create an annex without a job in the queue waiting for it. So the workaround, which I admit I don't love, is creating a service node that's basically looking for little files that are dropped by the jobs that are interpreted as a signal to help create an annex. But I still don't love this because hands-off annex creation just doesn't feel good. A lot of the sites require two-factor authentication, and then again, automated annex creation, you don't want to make mistakes and start burning your allocation. So there's definitely ways to cap that, but philosophically, I don't love this. So things are going fairly well here as well. Again, it's very much a prototype. We're dog fooding it right now, and here it's a dog picture, Greg, and it's definitely a dog. I checked. Deep sigh from Greg. Okay. But again, this is very much, yeah. But again, it's very much an exploratory prototype, and it was more about kind of learning these types of lessons than creating a tool, like I mentioned. So the things that I really want to hit home here are, it's not hard to build these DAG generation scripts, but we've talked to half a dozen or a dozen users who tend to do these hyperparameter sweeps, and everyone does it kind of their own way. And so I kind of got thinking of what would it take to do these things a little bit more natively in HTCondor? What can we do, within the DAG language to actually support these things a little bit more easily? So the kind of wish list that I came up with here is, what I need in this case is the ability to have sub-DAGs that have some kind of variable hook so that jobs within those sub-DAGs can kind of differ from other kind of regions of the DAG. And I'll explain and show this in the next couple slides. And then the other thing that would be really nice here, once that's added is, we have this queue from language when we're doing submit files. What if we had DAG composition that we could do fairly similarly? So, in my case, creating a subdag that, a suite of subdags that each have different parameters that are kind of slotted into these scoped regions. And so this is kind of what the DAG looks like now, and kind of I did some color highlighting here. If you're familiar with DAGs, you know that you need job descriptions, you need parent-child relationships, you need the variables defined, and each of these sort of different training runs, needs each very similar chunk of text. You're basically repeating almost the same thing over and over and over. It's not hard to do it programmatically, but why should people need to? Why can't we do something a little bit better? And so what I propose is something a little bit more like this. So you have a generic subdag that is more like a template subdag than a traditional one. That kind of leaves these variables to be defined in the same way we do in submit files. And then within the workflow, the DAG itself, you kind of have a special statement that generates and slots in the subdags from the variables defined. So kind of generate a subdag from this set of variables. You might look at this and say, well, there's not a lot of gain here, right? So, we had 10,000 lines before. Now we still have, the parameters here still, it's a very long, messy file. And I would say, yeah, that's true. But what if you want to do things like this? If you want to do these kind of sweeps, these sort of range-based things where we want to run, alpha from 0.001 to 0.1 by 1,000th, then we want to run beta from 0.5 to 5 by 0.5. Expressing this kind of in a very macro language like this makes it much more simple to kind of expand the experiment than having the generation of tens of thousands of lines that everyone is doing already. But very nice, simple, clean language that kind of sweeps away a lot of the variable between the different subdag regions. And it really helps with kind of messy combinatorics like you'd get in a hyperparameter sweep or kind of similar experiments to what we're running. So in conclusion, so the Annex integration with some NAIRR sites is working as expected. As Marone called me out on, I need to know my code and I need to be smart about the way I'm testing things. And I also need to read the site-specific documentation to know exactly what I'm getting into at each different resource. But really, we're seeing a lot of users who have hand-grown DAG generators, especially for hyperparameter sweeps. And so I think some new DAG features could really clear up the waters and make DAG a go-to tool for generating a lot of these workflows. Thank you.
We have any questions for Dr. Ian Ross,
AI coordinator.
AI coordinator? Oh, over here.
Definitive.
Tim?
So why would you, a lot of the access sites, so Delta, we do have hosted CEs for. So wouldn't that be an easier way than the Annex to get around some of the 2FA stuff and yada, yada, yada?
Yep. Again, we're just kind of experimenting with how might a user go about it first pass. And we think the Annex would be a likely first pass.
So I, having been part of the team for a long time, right, we always kind of had the struggle of how to guide users on appropriate scale testing, right, to inform a larger batch of high throughput computing jobs. And I see this as a general issue across AI use cases within and outside of, HTC implementation. So being a reviewer for the NAIRR pilot allocation process, we run into people frequently saying they need 10,000s of GPU hours, but with no indication that they have done any scale testing or even referencing literature. And I think a lot of folks just aren't even aware of how to do scale testing for AI use cases. And so I'm wondering, from your wisdom, those of the facilitators in the room, not just with the HTC, internal crowd, but those of you at campuses, what are the ways that we can all, as a broader research computing community, be advising folks to do scale tests? Is it, subsets of your training data? And then what are the users supposed to be looking for? Should they be looking at how much GPU memory they're using and how that scales in addition to how much GPU time? What's the guidance that we can really be instilling in the community of researchers using AI so that they can do testing and know how to plan the scale of a full size computation?
Benedict looks very eager to answer.
Yeah. So I mean, the problem is that they want to run before they can even crawl.
Yeah.
I mean, they want to go do OpenAI 20,000 GPUs stuff and believe that that's what they need because that's what they read. And I feel like the issue is like, have you tried specialized models? I mean, for IceCube specifically, I mean, a lot of the students are like, we need all this stuff. And I'm like, have you tried it on one GPU? And the answer is usually no. And I think that has to be the first step, that you guide them in a little bit pushing, I would say, not pushing back, but being like, what have you tried before, you know, they're coming to you and say, I want to do OpenAI, I want to do ChatGPT 04 or whatever. And sort of knowing what they want to do first instead of, or pinpointing them in the right direction or questioning their motivation in some respects. I mean, I don't know how big this model is that you're testing, but I mean, some of the issues could be like, you just need 2 GPUs rather than 1, or you need 8 rather than 1. But it's hard when they're just like starstruck in some respects.
So I get that. I think my question is more because understanding that, yes, on a one-to-one basis, that's what you would do. But we need to do this at mass scale, right? We're talking about needing to instill a culture of scale testing in the AI research community. We need to be able to put this into documentation. Here are the things to try first, right? And a step-by-step for how to scale on HTC. What is the first little test that somebody needs to do so that they know how many jobs to break their work up into, how long each of those, you know, they need to request short, long, medium, that kind of stuff. And
But,
maybe it means we need a broader conversation, right?
Lauren, the problem, and I think you can see even some of the symptoms of the problem in the presentation here, is that we don't follow Leonardo da Vinci's observation that simple is the ultimate sophistication. We are concerned about scale, where we don't have a handful of real examples that we understand. And yes, the problem is that, as Benedict says, I need to do AI. I don't have a clue. We heard from some of the resource provider that they get a student coming in and say, what is machine learning? But they got already 500,000 hours on some GPU because of other things. So we would love to have and I think Tony's team is a great example of researchers that have a specific AI, whatever, motivated problem, rather than saying, let's retrain some model that nobody cares about just to show we can retrain it a little bit faster. So I have not seen many. We have another press release that's supposed to come out tomorrow that describes actually a physics observation where the models were used, but a key element there is not the training. The key element is creating the data, which is a completely different thing. But I would like also to present or to frame the supplement in a different way. The challenge is, can we do training using high throughput approaches? And the idea is that eventually we believe that in science, ensembles of models are required to do science with the help of AI. That's the big picture. And we know that when it comes to ensembles, we need to do more of them. I don't want to use the word many. So how do we do training in a high throughput way, where the real obstacle is that typically somebody walks in and wants to do training and says, I need a GPU for 3 weeks. And that is not the throughput way. So the basic idea is, oh, it's epochs. And we can checkpoint epochs. So can we turn it for give me a resource for 3 weeks to give me a resource for 12 hours? This is the throughput mentality. And when we brought it up with Tony the first time, he was scared because he barely trusts models that are coming out from a single machine where everything, you know, the amount of neutrinos per square meter is known and it doesn't change. And now we are telling him, look, we'll train it by taking an epoch here and an epoch there and an epoch nowhere. And then we'll come back with a model. He says, he was ready to run for cover. And we said, okay, NAIRR gives us an opportunity to see what is the impact of running epoch here, epoch there, compared to running epoch here over and over and over again. And the challenge that we are facing is, can we test the impact of this distributed epoch training on the model at the end to get Tony less scared and to tell people that if they need to train, they don't need to go somewhere and get a GPU for 3 weeks. And they can do it 12 hours at a time. Although we are still trying to figure out whether Tony and his group lied to us. They said it will take 2 hours for an epoch. And at the moment, what I'm hearing from Ian, it is more like 12 hours an epoch. Now, we are still trying, this is an order of magnitude difference that we are trying to figure out what the heck is going on. Obviously, 2 hours an epoch is better than 12 hours an epoch, not in terms of the total computing, but in terms of the throughput computing model. It would have been great if we could do an epoch every 30 minutes. And then we could do many epochs for many models, for many, which we are not supposed to say that many times. Okay? So, but we need more examples, Lauren, real users that have an AI problem that, you know, and I'm sorry to say, I asked the allocation committee, how comes that allocation at that size were given and then nothing happens? But somebody has to look back and say, why did we give them that? And they didn't, something doesn't smell right. Okay, enough.